Hello, welcome to Meep's Math Matters, and in this episode we're going to look at how many presents you get in those 12 days of Christmas, other than the obvious cold I have. Now you may think we have already looked at this subject, because if I want to add up my 12 drummers drumming, 11 pipers piping, yada yada yada, 5 golden rings, 4, 3, 2, 1, we've already done this in episode number 1 when we were looking at triangular numbers, and we're adding up 1 up to n. We know this formula is n times n plus 1 over 2. So what do we have here? We have 12 times 13 over 2. 78. And we're done. Oh, that's a fast episode. Except this is all we got on the 12th day. On the 11th day, we got the 11 pipers piping, 10 lords a leaping, etc., etc., etc. On the 10th day, we got 10 plus 9 plus 8 plus 7. So something else is going on here, and we're going to have much more than 78 presents. So to investigate this, let's make a chart where in our first column is the day of Christmas, so the first day of Christmas, second day, etc. And then in the second column, we're going to put down the total number of presents received on that day. So we see our good old triangular numbers in this column. And then we're going to do this cumulatively. So on the first day, we have 1. By the second day, we have the presents from the first and the second day, and we're at 4. Okay, so obviously what I'm doing each time is adding. So adding the number from the second column to get the cumulative. And as we add this up, we'll end up with our final answer, 364. Oh, almost a full year's worth of presents. Now, just as with our triangular numbers, these numbers have a name, and they also have a formula. I'm going to give you the formula and the name, and I'll show you where that name comes from. I'm not going to prove that this works, but I'm also going to show you where these numbers show up. These numbers are called the tetrahedral numbers, and this is adding. Okay, so this symbol is summation, meaning we're adding up. K equals 1 to n, so we're going from 1, 2, 3, 4, up to n, and what we're adding is the triangular numbers. So tk is the kth triangular number, and we remember the formula for that. So k times k plus 1 over 2. And so the formula we have is n times n plus 1 times n plus 2 over 6. So let's see that works. If we put in 12 for our n, we'll get 12 times 13 times 14 over 6, so 2 times 13 times 14, and this is 364. Now there's a couple things that you might ask yourself. First of all, can you divide by 6? If you have n times n plus 1 times n plus 2, you need to make sure the sum is going to be a whole number. Not everything is divisible by 6. Well, you can prove that at least one of the numbers is even, okay, and at least one of the numbers is divisible by 3. Okay, so showing that at least one of the numbers is even, that's a parity argument. Well, if n is even, you're done. But if n is not even, then n plus 1 is even. So that's easy. The divisible by 3, again, if n is divisible by 3, you're done. If n divided by 3 gives you a remainder 1, then n plus 2 is going to be divisible by 3. And if n divided by 3 gives you a remainder 2, n plus 1 is going to be divisible by 3. So you are always going to get a whole number. Not a problem. And you can check out that that formula works for all the previous days of Christmas. So the question now becomes, why are they called tetrahedral numbers? Well, if you remember with our triangular numbers, okay, we could make a triangle. You have 1 plus 2 plus 3 plus 4. Okay, you're making a triangle here. Or you can do it 1 plus 2 plus 3 plus 4. And you can make a triangle out of it. And likewise with square numbers, you can make a square out of the number of dots. So what's a tetrahedron? I'm going to draw one, kind of. Okay, it's like a pyramid, except the base is a triangle. And if you've ever played Dungeons and Dragons, you may have seen a tetrahedral die, or tetrahedral dice, and they have 4 sides. So there's 4 sides, or 4 faces, I should say. And each face is a triangle. And that's a tetrahedron. So how do we do that with these numbers? How do we make a tetrahedron? So for my first day of Christmas, I have 1 present. On my second day of Christmas, I'm trying to draw this 3D. This is going to be a little hard. I have 2 turtle doves and a partridge in a pear tree. On the third day of Christmas, 3 French hens, 2 turtle doves, and a partridge in a pear tree. So at each level, I have my triangle, and then I'm kind of stacking these triangles up as a tetrahedron, kind of making a Christmas tree of presents here. It's kind of hard to envision 3D on a 2D drawing, but there you have it. And what's really neat is that all of these numbers, the tetrahedral, the triangular, and then some other numbers, show up in something called Pascal's triangle, which I'll leave for a later episode when I don't have a cold. Anyway, enjoy the holiday season and spread the math love. If you want to contact me, I can be reached at marypat.campbell@gmail.com.